Ooh la la!
Hi everyone and welcome to today's lesson where we will be looking at angles. In the previous lesson we touched on right angles, acute angles and obtuse angles, but in this lesson we'll be going into more detail on different types of angles including corresponding, alternate and vertically opposite angles. We will then have a look at how angles are made up within triangles, and in particular in this lesson we'll be having a look at equilateral triangles, right angled triangles and isosceles triangles, so stay tuned. In the last lesson we said that parallel lines are straight lines which have the same direction and so they never meet. But when we look at parallel lines as well, they can also be used to create various different types of angles, and that's what we're going to look at right now. So I've extended these lines so that I can illustrate the next type of angle we're going to look at, and that is corresponding angles. Imagine that if I draw a straight line through both of the parallel lines, and what this does is create two different angles within each of the parallel lines. And because this line is straight, and we know that parallel lines both have the same angle between them, then we know that both this angle and this angle must be equal, and that is what is known as a corresponding angle. And we've defined it down here as angles that are equal due to a straight line, which we have right here, crossing a set of parallel lines, which we have here as well. Corresponding angles are also known as F angles, due to the F-like shape that we can see here in between the two parallel lines and the two identical angles. And just a thing about corresponding angles as well, both this angle and this angle here are in the exact same position relative to one another. It's just almost like it's shifted down from here to here, almost like it's corresponding to one another. So the exact same position up here and the exact same position down here is known as corresponding or F angles. We can also say that both this angle, the blue angle, and this blue angle are corresponding angles as well, because they fit in between the parallel lines and they correspond to this straight line here. And the same as the red ones, they're equal because they're in the exact same position relative to one another. It's almost as if we've shifted this one down to here and have the same angle. Now let's have a little example. Let's say that this angle up here, the red one, is equal to 120 degrees. Well, we know that this angle is also 120 degrees because they're corresponding angles. And we also covered in the last lesson that in order to make up the angles of a straight line, they must add up to 180 degrees. So therefore, if we know this red angle is equal to 120 degrees, then this blue one must be 180 minus the 120, and hence we end up with 60 degrees. And because we know that this angle corresponds to this angle down here, then that is also equal to 60 degrees. So we said that if we have two parallel lines and a straight line running through them, then we can say that the angle in here can be shifted down and represented in the exact same way here, and both of them are equal. But this also presents us with a situation where we can identify more angles that are also equal. We can also say that both this blue angle here and the one down here as well are equal. Now why is this the case? Well, again, if we take the 180 degrees rule that we apply to straight lines, we can see that if this angle right here is the same as this one down here because they're corresponding, then this one must be equal to this one in order to complete the straight line. And these blue angles are what is known as alternate angles, because unlike corresponding angles, which lie on the same side below the parallel lines, but alternate angles lie on opposite sides of the parallel line and the straight line. So for example here, this angle lies below the parallel line and to the left of the straight red line running down, but this one here lies on top of the parallel line and to the right, and that's what makes them alternate. And an easy way to remember, or a good way to spot an alternate angles, is to look for the Z shape that these angles form. So if we take the two blue angles, and we can see that they follow this Z pattern right here. And if we see that, and the lines are parallel, then we know that we have two sets of equal angles due to being alternate. So the last type of angles we will be looking at are known as vertically opposite angles, and these are essentially what they say in the name. They're angles that are vertically opposite. But this time we don't need parallel lines to form them. All we need are two crossing straight lines, as we can see here, and then we can identify vertically opposite angles. To give an example, let's take this top angle in here. Vertically opposite angles will be the same if they lie opposite one another as such, and that means both this top angle and the bottom angle are equal. And the same can be said for this angle in here, which is equal to this angle in here, because they're vertically opposite. And the reason that they're equal is, if you think about it, when you have these sort of two crossing lines, imagine it's like a mirror, and we can see that if we draw this line down and imagine that we have a mirror in here, we can almost see that this side here is exactly the same as this side here, and if they're exactly the same, then the angles are going to be the same. Okay, so now let's have a look at an example problem. We can see that in this problem we have two parallel lines indicated by these arrows right here, and also a straight red line that runs through, and we've already been given an angle, as we can see here, 40 degrees, and what we have to do is find out angle A, B and C. So beginning with angle A, we know that in this case it is two straight lines crossing over each other, and if that's the case, we know that we have vertically opposite angles, and in that case we can then say that A is equal to 40 degrees because of that. So moving on to angle B, we know that if we draw what looks like a Z shape between this angle of 40 degrees and angle B, we can actually see that they are both alternate angles. Therefore, angle B must also be equal to 40 degrees through the principle of being alternate angles. And finally, let's calculate angle C. So we know that in order to make a straight line, the angles must add up to 180 degrees. Therefore, if we add angle C and this angle of 40 degrees together, they must be equal to 180. Therefore, angle C is equal to 180 degrees minus 40 degrees. Therefore, angle C is equal to 140 degrees. So in this problem, we use the rule of vertically opposite angles to calculate A, alternate angles to calculate B, and the rule that in order to make a straight line, the angles must add up to 180. Therefore, angle C is equal to 140. Okay, so now we're going to move on and have a look at triangles and how we see different types of angles within them. Well, one thing that we can identify straight away, and you might already know this, is that the actual name triangles means three angles, as anything with tri before it often means three. So when we see a triangle, it's obvious to see 1, 2, 3 points, and that means there's three angles within the shape. And just like a straight line, one funny thing about triangles is that all of the angles add up to get 180 degrees, regardless of the shape or size of the triangle. Each of the angles always add up to equal 180. So let's say, for example, we have a triangle that has angles that are known of 65 degrees and 30 degrees, and we want to calculate what this angle is in here. Well, if the angles have to add up to give 180, we can say that we'll call this angle A, and angle A would be equal to 180 degrees minus 65 degrees minus 30 degrees, and that would equal 85 degrees for angle A. Okay, so the first type of triangle we're going to have a look at is called an equilateral triangle. And in the name itself, we can almost get a clue to what type of triangle it is. The name equilateral literally means equal sides, meaning that each of the three sides that make up a triangle are of equal length. And that's what these little double dashes indicate. It means that this side is equal in length to this side and equal in length to this side. But this also means that all three of the angles that make up an equilateral triangle are also equal, they're all the same. And because we know that each of these angles must add up to give 180, therefore each individual angle, we'll call this one angle A, we know that angle A has to be equal to both this one and this one. Therefore, we can say that angle A is equal to 180 degrees divided by 3, because the 180 degrees has to be divided up equally between each of the three angles, and that gives us a value of 60 degrees. So anytime we have an equilateral triangle, all of the angles are always equal to 60 degrees. And now the length can be anything. This may be 1 meters, and that means both of these sides will be 1 meters, or it could equal 50 meters, 100 meters. The length does not matter, but the angles within an equilateral triangle are always 60 degrees, because 60 plus 60 plus 60 equals 180, and that's the rule, that in a triangle all angles add up to 180 degrees. Okay, so the next type of triangle we're going to look at are right-angled triangles. And how we identify a right-angled triangle is the same as before, where if we see this little right-angle symbol, then we know that it's a right-angled triangle, and also that this angle is equal to 90 degrees. So if we have a right-angled triangle and we want to calculate, for example, this angle here A, and we know that this angle here is 40 degrees, well, we can say that angle A is equal to 180 degrees. Take away the 90 degrees we know that makes up a right angle, and also take away this 40 degrees that we've already been given as well. Therefore, angle A is equal to 50 degrees. And now the last type of triangle we're going to look at is called an isosceles triangle. And the difference between an isosceles triangle and an equilateral triangle is that an isosceles only has two sides that are equal, as we can see here by the lines that have the double dash through them. Only two of the sides, both this one and this one, are equal. And this is also the same with the angles. Unlike in an equilateral triangle, which had all three angles were the same, in an isosceles triangle here, only two of the angles are the same, which is this angle right here and this angle here, because the rule is the angle that's different from the rest, this one here, is the one which connects both of the equal lines together. So we know that both of these lines are equal and both of them connect to this point here, and it's always this point that is the different angle between these two. So if we know that, for example, this angle right here is 75 degrees, well, we know that this angle here is equal to that, so therefore that must also be equal to 75 degrees. And then finally, to calculate this angle up here, well, we know that all of the angles must add up to 180 degrees in a triangle. Therefore, if we call this angle A, we can say that angle A is equal to 180, take away 75, and another 75. Therefore, angle A is equal to 30 degrees. Okay, so let's have a quick recap of this lesson before we finish off. We said that if we have two parallel lines and one other straight line running through them, then the angle that that line makes with the first parallel line is the same in the second parallel line in the exact same position. We also said that the angles on the opposite side of the straight line running through the parallel lines are equal as well if they make this Z shape that is found, and these angles are called alternate angles. We now also know that if we have two straight lines that cross each other in this fashion, well then the opposite angles are equal to one another, and that is just simply known as opposite angles. We now know that for triangles, all three angles within inside the shape must add up to give 180 degrees. We said that an equilateral triangle is a triangle which has three equal sides and also three equal angles. We know that a right angled triangle is just simply a triangle that contains a right angle, as symbolised by this here. And then finally, we said that an isosceles triangle is one which has only two equal sides and two equal angles. Thanks again for watching, and I'll see you in the next video.